So we are being recorded today. Welcome, Jake. Hello. Billy dropped the class. He don't. Who did Billy end up sitting down? Is he sitting right next to you again?
No. I don't think Billy's here yet.
The class? Right. So, today in class we're going to kind of apply a little bit of what we learned yesterday. Let's recap. What did we get out of yesterday's class? Tell me what you got. What did you get?
Oh, the desert has the greatest potential for groundwater contamination.
And why is that?
Passes through layers faster and acids don't have a lot of potential.
Why is it passing through faster?
Because they don't have
It has what?
clay.
Less clay? Is that what it is? Is it less clay? So
Yeah, because
this soil right here could be groundwater contamination? So what did we learn yesterday? We learned that the structure of these soil profiles matter, right? They matter. They matter to farming, they matter to water conservation, they matter to nutrient conservation. And we have a big problem with soils, right? What's our big problem? What's our overarching problem?
eutrophication.
Eutrophication, thank you. Pollution. What's eutrophication again? So let me just recap it quickly, that way ocean, our kids that are coming into the class understand what it is. Anybody but Rio? Rio's killing it, so let's give him a break.
Which
What?
one there's no like oxygen in the water.
Right, that's the end result, is hypoxia, an oxygen depleted area of water. And that's a big problem right now. There's tons of articles in the news right now about the amount of oxygen coming out of the oceans. Oceans used to be a great source of oxygen because of all the activity with photosynthesis, and now it's being reduced. That's a problem because we kind of need oxygen to function and be smart. Lower oxygen, stupid decisions, right? If I was to make you guys do 1,000 jumping jacks and then try to solve math, you'd be way slower and way less productive than if you did it with all the oxygen you need in your brain, if I deplete your oxygen. All right, so yes, what is eutrophication? How's it cost?
Excessive nutrients.
Excessive nutrients. Which nutrients? Nitrogen and phosphorus, which are used in farming, right? Every organism needs nitrogen and phosphorus, and plants are a best source for fixing that into usable forms for us. And so paying attention to soils means that we can prevent some issues. Let me show you a couple images, and we're going to kind of connect the dots. So I'm going to be working from our notes that are posted on the topics page, okay? We'll read along there, and we may get to an activity today. We'll see how it flows, okay? We'll set it up here. Were there any questions on the assignment last night with finishing the lab? And I am going to take it and take a look at how you constructed your thoughts and stuff. It should be an easy grade because it was in-class work. So I'm going to take that up in a second. Any concerns with that before I take it?
Can we like go over like why A and B are similar?
Why A and B? What's A and B?
Horizon.
Why A and B horizons are similar?
Question 4.
Yeah, that didn't really.
Well, let's take a look at A and B. A and B of which bio or in general?
The question
It's
is
just in general.
The desert.
It was for the desert, right?
For the desert.
Yeah. So what was your horizon A made of in the desert biome?
It was
rock, sand.
Made of sand. What was your horizon B made of? Sand and clay. Is that right?
Yeah.
Did I hear that correctly? Okay. So what was the question again?
Why do desert habitats have a larger sea horizon than other habitats? Why are the A and B horizons similar? How does this relate to the yearly rainfall that deserts receive?
Okay. So it was asking about soil formation in a desert. Okay? Remember our process for soil formation? what are the 5 factors we need to form soil?
Biota.
Organisms is one of them, or
Climate.
biota, yes. What?
Climate.
Climate?
Is that the CT platform?
Yeah, it's Connecticut pot. So we go in order of CTPOT, we have climate, we have time, we have parent material, organisms, and topography. So if we think about a desert, like, the thing that's really important about this soil layer stuff is that this formation of soils in the layers is dependent on location and time, right? And of course, all that other stuff that we just named, those 5 factors. So when we look at a desert, what is different about the desert? It has parent material, right?
It's weather.
That's the thing it does have that's in common with everything else, right? What about the weather?
There's not a ton of.
Very dry in there.
It's very dry.
Yeah, it's pretty uniform weather. Like living in a desert is pretty warm a lot of the time. There's very little rainfall. There might be some variations in temperature, but that doesn't really help with weathering a lot. So it's mainly heat and wind that are weathering agents. We compare those weathering agents to another location, like here. What are some other factors involved in weathering?
Snow.
Snow, freezing, thawing, and what else? What's the big thing that's missing in the desert?
Rain.
Rain. Rain is a significant weathering agent because it's physical and chemical in the way it breaks down larger materials, especially minerals, right? Water is charged on either side of it, right? It's negative and positive. It's a bipolar, probably not the right word for it, what is it? It's a polar molecule, right? And that makes it attractive, like say sexy. And I use the example of the insane relationship, right? It just tears up a relationship. That's what water does. So water's lacking in the desert. So that's why you see this uniformity in the soil types, right? A and B horizon look pretty darn the same, don't they? What's the only difference?
One has half a tablespoon of sand,
And the other one has
just 1/4.
clay. Clay's the difference, right?
Oh, yeah, sorry, yeah.
They all have, it has sand throughout the whole thing except a little bit of clay. Why? Where are we getting the clay from?
Water.
What? The weathering process, which is lack, right? All right, so let's go through the question again. Say the question again.
Number 4. Why do desert habitats have a larger sea horizon than upper habitats? Why are the A and B horizons similar? How does this relate to the yearly rainfall that deserts receive?
Okay, do we feel like we have an answer here from our little discussion? What do you think the answer is? Anybody but Rhea? Rhea's killing it. Everybody- Somebody else talk, what did you get?
Purple.
Well, there's not a ton of weathering, so,
And there's not a lot of rainfall.
and so that
That's
there's not a lot
amazing.
of variety, and there's not a ton of play that can come.
Excellent, did you hear what Tad said? Does that make sense? Rhea, did that help you?
Yeah.
Did that help others?
Yeah.
So, like, when we look at places that have a lot of more dynamic climate, the more opportunities for water exposure through rain and wind, fog, and all that stuff, you're gonna have a faster rate of decomposition, a greater rate of weathering, a greater rate of organisms doing physical breakdown and adding their bodies to the soil matrix because they decompose when they die. In desert, you'll have a lot of that hanging around, right? Make sense? Okay. So I'm gonna take this up, or if you guys should just pass it down the row, I'm gonna look it over, and I'll give it back to you next time we're in class. So, at this point in our soils chapter, we've got this idea about particle size, and that the smaller the particle is, the more surface area it has, and therefore you can pack in more of it and create a higher density of particles with one type of particle than the other, right? This is a little chart behind me. Yeah, it's working. And this is a soil texture chart. And you can figure out what's in soils through the subjective experience of feeling the particles in soil. So like the soil in front of me, we could go through a little test and we can figure out approximately what type of soil it is. We can take through some other tests and see how it performs and sticks together and is dense or compacts together to allow for space for roots or not, or space for roots for water or not. The issue here is that if we have a lot of clay, like we saw in our little lab, and by the way, it's still going there. Is all the water drained out of all these over here? I haven't even checked. Looks like, yeah, all of them drained over the course of almost 24 hours. You know, so they eventually did it. The clay doesn't hold it forever. It does slow it down. And so more clay, though, probably slow it down even more. And if you compact it, it's really tough. And especially if you heat it up. You ever compact clay and then heat it up? Never? Well, this is clay. You could do ceramics too, similar. It's the same thing, it's a mineral, compacted. You put a glazing and stuff on it when you do ceramics. This is probably ceramic. But clay pots and stuff were popular in a lot of cultures early on because it held water. You know, so you do that naturally, you get rock again, essentially. And we have porous rock, sandstone stuff. Water can migrate through it very slowly. So if we're farming and we're worried about farming, we're worried about pollution issues, we're worried about feeding the future generations, the soil becomes a big deal. And its consistency or its clumpiness is a really important factor. And we can influence its clumpiness through how it gets weathered. We increase weathering through the farming process, don't we?
Do we?
Yes. A good example is right here. So when we till, every time we till, we're breaking apart the soil particles. And if we have machines, we're also compacting it together. So we're changing the structure of soil over time. So the more times you do it, the greater the effect you'll have. And so that's why places like Mesopotamia, the Fertile Crescent, no longer fertile. Right? Iran is not known as the breadbasket of the world anymore. Right? By the way, just for notes for yourself, this is slide number 25 out of 111. Just point out where it is if you have to study it. Okay. All right, so we want to figure out how to apply this knowledge to farming practices where we don't degrade the soil, because this is a big problem. So let's talk about this problem globally, and then we'll start focusing on solving it. So I'm gonna move through a couple slides that I don't feel are super important. So if we're looking at agriculture and soils, one of the worst forms of agriculture right now, and it's happening all over the Amazon, is this one right here, a slash and burn agriculture, which has been promoted by the current Brazilian government, unfortunately. And this type of agriculture brings together deforestation and farming. And so basically what you do is you go into the forest, you cut down the forest, extract the stuff that is of monetary value at this moment in the market, you sell off all that stuff, and anything left over, you burn. Why are they burning it?
So the nutrients on the soil.
So you can allow for like regrowth, right?
Both of those, yeah. So
So they
you burn the leftover stuff to reduce competition, but also to help lock in some nutrients into the soil. What's the problem with that though, with rainforest soils? What did we notice yesterday with rainforest soils? We did temperate rainforest, not tropical. What did you notice about our rainforest experiment yesterday with the water? What happened?
It held it the longest.
It held it the longest, the water piled up, and so therefore, if we had a rain event in a temperate rainforest, where would most of the water be? On the surface, thank you. And it takes a while to percolate in there. So if you have a big storm, a lot of it's gonna run off into the river, right? You get flooded, right? India, monsoon season, flooded. But tropical rainforests, like the Amazon, are gonna behave a little differently. What do you think is gonna be different about a tropical rainforest compared to the temperate one? Who built the rainforest soils yesterday? Who built that? Griffin, okay, Griffin. Why did the water take so long to pass through?
Because there's so much clay and
Right.
dense materials.
Thank you. So, clay is formed through parent material, organisms, time, climate, and topography, right? So if we have a hotter climate with more organisms, are we gonna have more or less clay?
More? Yeah,
Yes, absolutely. Because it's smaller particles, right?
yeah.
So they have more weather to make more clay. So they have more clay, so what's the problem here if we do slash and burn? And they burn it, so they want the nutrients to get in the soil, what's gonna happen?
Oh, you're making more clay, because it's,
What's gonna happen to the nutrients? Are they gonna seep down into the topsoil?
no,
No. How thick was your topsoil? Was it a thick layer?
it's pretty thin.
It was pretty thin.
Yeah.
All tropical forests, in all tropical regions, from Vietnam down to Gambia and Africa, those tropical areas, they don't have a thick amount of topsoil. They do have a thick layer of clay. Why do they have such little topsoil? What would you guess? You guys got this, you know this.
More erosion, more watering.
Right, a lot of it's moving away. What else? What do we know about tropical forests? What's the first thing you think of when I say tropical forest? Seriously.
High precipitation.
High precipitation. What else? Good, you got that A bio. Remember, A, B, C, D, E's.
Trees.
So lots of trees. Trees, okay, good, lots of trees. Diverse amount of trees, right? So topsoil is gobbled up in a tropical rainforest. It's a very thin topsoil because all the nutrients are being used by all this competition. From fungi to trees and vines and animals. So when they burn it, it doesn't get a chance to leach through the soil. Here's a picture of Swidden agriculture or slash and burn. And you can see the soil profile there. Can you pick out the A layer?
No, it's all uniform.
Right, the A layer is super thin. It's maybe a couple inches. Do you think the granite state has thin topsoil? Rainforest is similar. Yet, they're practicing this. Why? Why are they doing this? How, does this seem,
Because they think it's good.
It's easy.
but they've been doing this for 50 years. So why would you continue something that's not good?
Because you want more land.
It depends on what good is, right?
Cheap.
Yeah.
It's cheap.
That's it.
Cheap and easy. What are they actually gonna grow once they've cleared off all that diversity and all that great wood product? What are they gonna grow here?
Soybean.
Crops. Okay, you're right. But let's be very specific. What do we know? They may do some soybean
Okay.
and cattle. It's grass and soybeans. It's pretty much it. Palm oil, maybe the other.
Because they're big, like they export a lot of beef and meat and things like that.
I'm sorry, they what?
They export a lot of meat, so they need like areas where they can have them.
Right, so they're banking on the meat eaters. They're gonna make grass. The problem is, it's not gonna support grass for very long. So what do you have to do if the grass doesn't feed your cattle, and you got a lot of cattle?
Burn more.
You're gonna cut down more and burn, right? So we got this feedback loop, right? Is that a positive or negative feedback loop?
Positive.
It's a positive feedback loop, it's leading towards destabilize.
Oh, because positive is bad.
Yes, it's destabilizing. It's not saying good or bad, destabilizes. Okay, so take a look at Iowa. Look at that soil profile. Okay, you can see these profiles. What's at the top? What's that right up here?
Grass.
What layer is that called? we're gonna practice the terminology.
Organic.
Organic layer, the O layer, good, good. Right after it is
Topsoil.
topsoil, or the A layer, right? Then we have this E leaching layer. You saw that in our image before?
Yes.
What does leaching mean? Did anybody figure that one out from the reading?
Enable water to seep through.
Right, water and nutrients are dissolved in there, yeah. It can be, sometimes this alluviated layer or the leaching layer will show up, and sometimes it won't. So remember, the thing about soil profiles is they're not gonna be just like the textbook. They'll skip some layers. They may not have some layers due to disruptions, due to human intervention, due to climate, time, air material, or organisms in time. So you can see these different layers here. And so this topsoil layer, the first one, how deep do you think it is? Well, actually, you can see how deep it is. How deep is it? There's a measurement on the
1
image.
foot.
Yeah, it's pretty deep. Now, why is that one deeper than the tropical rainforests?
Because there are less plants to use all the nutrients.
Okay?
There's less like weathering.
There's a different type of weathering, yeah, less weather. So they don't get as much rainfall, there's not as much of that chemical and physical impact. There's a lot of wind, and there's not a lot of topography either, so it's pretty evenly distributed. What was your other thing?
Compaction.
There's not, that is a problem that's occurring out in the plains of North America, but naturally, it has been a very deep topsoil because it's like a Goldilocks effect. It's got the just right amount of weathering, just the right type of climate and organisms to build soil relatively rapidly and keep it there. It's still pretty tough. How long do you think it takes to grow topsoil? Here, right? It's gonna vary based on climate, but here in Iowa, or, but how long?
Long time.
That's not a time. Let's go, come on.
5 years.
It's not fifth grade, let's go, come on, give me some years.
8 years.
8 years.
100.
No,
No, 2
Yeah.
years.
longer.
20.
Oh, 10,
10.
16.
We're talking decades.
30,
We're talking, on
40.
average, it takes 50 to 100 years for 1 inch of topsoil to be built up from natural processes. We can accelerate that through composting and some other stuff. But right now, the natural process, on average, 50 to 100 years for 1 inch. So it's slow. In the tropics and stuff, they can build it up faster, but it usually gets used up by all the organisms. It's hard to hang on to. We can manage that. There's a solution there. All right, so let's skip this one. So here's our problem. Here's our problem. These two terms, soil degradation, land degradation. We're losing quality and productivity of our soils due to the way we practice agriculture. A lot of agriculture requires deforestation first, right, to get there. An example is here in New Hampshire, back in the 1600s, 1700s, we were totally deforested except for the highest parts of the mountains. Cut down everything in order to grow grass for sheep, for crops, for those sheep, for grazing. Of course, we've gone away from that. So the degradation of soil quality means it's getting compacted, or it's washing away into water systems where we can't recover it, or it's getting blown into the air and drifting into coral reefs in the Caribbean, which is true. We're losing it. So we gotta figure out ways to stabilize it. What's the difference between soil and land degradation? What's the difference? There's not much difference. So soil degradation is measuring the quality and the productivity of soils. And then land degradation is just the overall change in the landscape, mainly in biodiversity. So erosion and salinization are big ones. And salinization is not a term we've talked about yet. Does anybody know what this is? Want to take a guess?
How salty it is.
Boom. Thank you. How the heck can we make the land salty? What the heck are we doing? We don't water our crops with seawater, so what is going on here?
Oh, it's part of the, like, the chemical reaction. It spits out like that NaCl stuff, right?
What does?
Photosynthesis.
It spits out salt.
Or it's like, it's one of the,
Good
The-
concentration.
I think, right?
Concentration, hydroxide and carbon.
The
OH.
concentration of hydroxides
Yeah.
and carbon
Yes,
can make it salty.
well, it changed the pH.
Yes, that's not what we're talking about. Salinization is about saltiness. Where the salt's coming from is that a lot of farmlands like Iowa and New Mexico, they're pulling water out of the ground. And in the ground, there's dissolved minerals. You pull that up onto the ground, onto the surface, the water gets used up by the plants and evaporates and leaves the nutrients behind. What doesn't dissolve into the air? Salt. It stays on the ground. So if you water a landscape a lot using groundwater, there is a greater risk at leaving a bunch of salt on the surface, and that'll change osmosis and potential of moving nutrients in and out of roots of plants over time. That's what happened to Fertile Crescent. It's part of what happened there, so it's oversalted the lands. We'll get more into that. Okay, so soil degradation, land degradation. It's happening in China in a big way. And I know that Michael's done a lot of habitat restoration in China, and you might have seen some of this. I mean, China's a huge country, and over the years, as they have become more and more populated, one of the struggles they've had is a dust bowl, of which America, we've led the way. We've had our dust bowl as well. Has anybody ever studied the dust bowl?
Yeah.
Yes. It is a great example of soil and land degradation. Not only does it reduce the soil productivity, but then it reduces the productivity of life on the landscape. Okay? So China and other countries are having the same problem. Why am I bringing up China? Why does China matter in this? Elena, why does China matter?
We're a big country.
That's right. You're huge and you're important. You have, China has led a lot of global cultural revolutions. Paper, fireworks, gunpowder, pasta, all invented by the Chinese. And agriculture is a major part of it. So, all right. I'm gonna go through it. I'm not gonna look at it. You know these terms, right? Do I need to dwell on these terms? These are boring, right? Do you know what deposition is? Okay, so maybe I should stand. So erosion, I have an erosion machine we're gonna play with eventually in class. We're getting there. I feel like since today's a short class, we should just spend it on this and do action stuff next time. So deposition is when that eroded material settles somewhere. And we'll use the word deposition for a lot of stuff. It's whenever a nutrient or an element or whatever pollutant we're looking at, wherever it settles. So acid rain has a higher deposition rate in higher altitudes. Mercury has a higher deposition rate in New England because of weather patterns. And soils have a higher deposition rate where? Where do soils end up when they erode?
In the ocean water.
In the water, could be in the water, yeah. They often end up in the low places, wherever the bottom of something is. Valleys, right? It is no surprise that we look at Egypt, or we look at some of the other great civilizations that are nestled in valleys or around rivers where flooding and deposition of nutrients is highest. Because now you can do agriculture, you don't have to leave, and you can stay right there. Valleys are always awesome. Montana, the Valley of Montana, amazing. Valleys in LA, amazing for growing food. Unbelievable, because the soils have settled there. They've deposited. Cool? Slide number 36 for those watching. All right, I'm gonna move on. We'll get to solutions while we can. Can I move on? Is that okay?
Yeah.
All right. So that's erosion, yeah. So erosion occurs with wind as well. We know that. So let's talk about stopping this stuff. You know, what we do on a farm can increase or decrease erosion. And oftentimes we're increasing erosion by a factor of 10. By a factor of 10. But if we practice conservation farming, like no-till, we can reduce it in a significant way and conserve soils and reduce land and soil degradation, which is important to feeding the world, right? So a couple of facts on here that are highlighted, right? More than 19 billion hectares are suffering from erosion. U.S. farmlands lose 5 tons of soil for every ton of grain that's produced. That's not a great turnover, especially if you had to pay for it. What's that?
What's conservation farming?
We're gonna get to that. I know. God, I'm glad you asked. I'm gonna show you some examples. Okay? So just by mitigating and reducing, not mitigating, but reducing erosion, we can help feed the world. Like one of our solutions that we looked at was do farm better. Do more on the farms we have. Well, this is significant. Look at the last part. Erosion is reducing crop yields by half in some places. Like, that's not good. But we can easily stop it. Let's take a look at some solutions. Here's Madagascar. When you deforest regions of Madagascar, which is a dense clay region, because it's tropical. Look at that river. Chocolatey. Here's another example of erosion around farmlands. You know, we don't control it, right? It leads to eutrophication. You see that increase in turbidity you can see from space. My God, that is bad news, right? Okay, so let's talk about it. I'm gonna move past all these terms. We'll come back to it. Dust Bowl, horrible picture of Dust Bowl. This is the fast fashion in 1940s, 30s, sorry. Hey, you going to church today? Yeah. Don't forget your gas mask. Modern. There it is. Sweet. All right, so let me get to solutions. Okay, number 1. You can protect soil in so many great ways, and these things, like those grinning guys at the very beginning of this study, this whole chapter, they were grinning about no-till. No-till is a great way to do it, but there's more. Here's 3. Crop rotation, contour farming, terracing. And I've got images for each one. So you don't have to dwell on writing it all down. You can look at it and write it in your own words. But every single one of these increases nutrients in the soil, decreases erosion, and has a good chance of decreasing water runoff. So it conserves water. Okay? Let's take a look at it. So crop rotation. We read about this with Omnivore's Dilemma, but it's not like a top secret idea. People are practicing crop rotation all the time. You move through your rotation of what crops you do in a yearly cycle. So here's a circular one. So year 1 on field 1, you plant onions, and then you rotate, and then you move it around each of those fields. And that's what Joel Salatin in Omnivore's Dilemma was doing with cattle, chickens, and pigs and turkeys to grow grass. He rotated them around. And this is stuff that's been done by traditional farmers forever. And we've kind of forgotten their way in the pursuit of money and thinking that chemicals will save everything. But by rotating it, you don't till, you're gonna really conserve nutrients, soil, and water, because it's gonna be able to seep into the soil way better. Crop rotation, pretty easy. Labor intensive though, that's a negative. It's work. We'll move to the next one. Contour farming. So not every place to farm is level, right? And we know that soil formation is based on topography. So places that are higher up tend to lose their soils quickest because of gravity. And so in order to stop that, you farm along a contour line. Let me show you a different image that'll be better. Here it is. So you have your, and I have a friend in town, Sophie Bianchi, maybe anybody's on the dance team? No, nobody's on the dance team. Sophie does this kind of farming. So what it is here is you have your farm stuff here. You grow your plants in here.
Oh, you see this all for rice farmers?
Yes, yes, we show that. That'll be a dramatic version of it called terracing. But by doing this, as you get erosion, you have water, you have a rain event, the soil's going to be pushed downhill naturally, but you create these traps, this soil trap, little drainage canals, and it'll collect the soil there and kind of build it up instead of having to continue to run downhill. And then the water will stop and slow down there as well. Here's a better look at it. So you make this little ridge. You got your plant right here. This is contour farming.
What is so good about it? What?
Well, if we farmed on this hillside without it, the soil at every rain event is gonna experience heavier erosion, right? Erosion is simply the movement of soil from one place to another. And when we have water erosion, water's powerful. Who here drives a car? Anybody drive a car? You know not to drive through more than 6 or 3 inches of water because it can move your car, which is over a ton. That little bit of water can still lift you up and throw you in the ditch and flip you over and break your neck. So you don't mess around with water. It's a powerful force, especially when it starts to move. It'll lift up stuff. It'll lift up all the soils. It'll lift up all your all your cash crops. So you lose if you allow water erosion to continue. How much time do I have, Tom? 2?
I don't know what it is.
10 minutes, good, I'm on fire. But are you with me? I know these examples are good. We're going to apply them to my erosion machine. You can see the erosion machine over there. You see it's a tilted, sloped landscape. It's by the window. We're going to design some ideas. I'm going to give you some scenarios in the future. We're going to have to figure it out. So this is one alternative. You can do combinations. You can rotate the crops along the contour line. Pretty sweet. Here's extreme stuff. Here's what Rio was saying, terracing. This is dramatic. Peru, Japan, China, Andes, Himalayas, farming. And terracing, this is dramatic contour farming. They're creating out whole little plateaus that'll trap and hold water and keep it there. And rice likes to be totally soaking wet all the time, and it's a huge, important grain for humanity. So this is nothing but rice farms. Probably in Cambodia or Vietnam too. Terracing. Why is this a good soil conservation practice?
Because since it's high up, like on like a hill, a lot of this soil is going to run down. So
It's slowing down erosion and keeping soils and nutrients long enough in contact with plants so they can convert it into yummy, yummy food. Here it is there. The traditional picture. Rice farming, right? Using terracing.
Seems like hard, it would be hard to set that up.
Yeah, that's some serious work right there. And you gotta be careful when you set them up that you don't have to set it up again because machinery and stuff is compacting the soil and you wanna reduce that. But you see they're doing it all by hand. Okay, another way you can conserve soils and nutrients and reduce pests is through a process called intercropping. So this is even better. And you add these all together, depending on your circumstance, you can have really good results. I'm going to show you a picture of that in a second. 2 more. Shelter breaks and then no-till or conservation tillage, which we've already talked about. So here's intercropping. So intercropping is really cool, and I practice that a lot over here at the little garden. And all you're doing is you're doing rows of food, but these crops are going to have other crops right next to it. Has anybody heard of this before? A lot of us practice this already. Have you ever heard of the Three Sisters planting? It's a Native American style of garden. You know about Three Sisters?
Yes.
What is it?
Corn,
Corn?
something,
Something?
and.
Something else, okay. He's got the corn part. Anybody wanna help him out? Come on. Three Sisters is corn,
Right.
beans, and
Right.
squash. Rice is not American. And you plant those together, all three of those, they actually share nutrients between the three, and they help each other be more resilient. So just like your hockey team or your football team, the diversity of skill sets, you do that in your garden plot, you have some good pest resistance going on. You have some good water conservation going on. You have some good nutrient cycling going on. Here it is up close. One of the best companion planting you can do is basil, tomatoes, and marigolds. All insect pests hate marigolds. They think they smell like whatever. They're repellers. They're natural pest repellent.
Those are the flowers.
Yeah, they're the pink, they're the yellow and the orange. And so you do this intercropping like this. This is still labor intensive though. That's why this isn't super popular with huge farms. This is a lot of work. Right? This one's shelter belts. What do you think shelter belts are doing here? Notice our landscape.
Preventing the wind.
Yeah, this is all about wind erosion. This is a Kansas, Iowa plains farming technique because the winds are immense. If you go out to South Dakota and spend some time out there, the winds are real. They're real. And so by putting up trees and bushes to create blocks from the wind, you can reduce some wind erosion. It's a little linear, but gets the job done. It's better than spending all that money on synthetic fertilizers to replace it. Whoops. No-till farming. Okay, so that one we've already talked about, right? Okay, so let's leave it there. So we have several different solutions that can help improve soil, reduce erosion, and conserve water. Those are three big steps that turn into, when you look at no-till, for example, also conservation of money. You're not spending money on other stuff. We'll go deeper next time, okay? Does anybody have any pressing questions about this chapter at this point? Without done, you read it, I think so, it's next week. You have time. I'll make sure you know what you need to know. You probably know what you need to know already. Anyway, guys, have a great Wednesday. Have fun in your competitions or whatever. Enjoy your afternoon.
Yeah, it's like it doesn't even count, it's more like a gem.
Welcome. Thank you.
Yeah, it's a
Thanks,
proctor.
everybody.
I don't have to go into it.
Yeah, buddy. All right.
Thanks,
Yeah, have a good day, Bill. Tag. Checking the tag. Escape me. How you doing today? Better?
Yeah. No, I don't know. I don't know. I think I need to go to a doctor.
That's too bad. Hopefully you'll figure it out.